And then notice it doesn't say birthday one word. It says birthday. All right, go ahead.
Your teacher is planning to give you 10 problems for homework. As an alternative, you can agree to play the birthday game.
Yeah.
Here's how it works. A student will be selected at random in your class and asked to guess the day of the week, for instance, Thursday, on which one of your teacher's friends was born. If the student guesses correctly, then the class will only have one homework problem. If the student guesses the wrong day of the week, your teacher will once again select the student from the class at random. The chosen student will try to guess the day of the week on which a different one of your teacher's friends was born. If the student gets it right, the class will have 2 homework problems. The game continues until a student correctly guesses the day on which one of your teacher's many friends was born.
I had trouble finding 7 friends.
Why don't you just...
Your teacher will assign a number of homework problems that is equal to the total number of guesses made by members of your class. Are you ready to play the birthday game?
What do you think?
It's not a binomial.
No.
It's not. Good point.
How about we just do the 10 problems?
You don't want the stress? All right.
Why don't we see
You
what
can
the
just put it on the
probability
board.
of getting less than 10 is, and if it works.
All right, well, let's just pretend we're playing the birthday game. All right, so the first person up is Miss Nancy Kovanoff. All right, so Allie, you guess what day she was born in the week.
What day of the week she was born, what day of the week that her birthday falls on this year?
No, when she was actually born.
Oh.
The day of her birth.
Did you
Wednesday.
actually ask them
Pardon?
this?
Yeah, I did. All right, she was born on a Monday. All right, how about Miss Janine Powell?
That's you.
I'm my friend.
Tuesday.
All right, it's Bailey's turn. So you got 1 homework problem so far.
I don't want to be the one.
I'm gonna guess Friday because you're awesome.
Wednesday, okay, Miss Grace McManus.
Oh, I love her.
Friday.
Friday, it is Thursday. 3 homework problems.
I don't
Wait,
want to
really? What? What's happening?
We get a homework problem for everyone we guess wrong.
And
Okay.
as soon as someone guesses right, we stop. All right, and then different friends.
It's not real.
So the next one is
It's
Stu Jones. What day of the, you're guessing what day of the week he was born.
But they didn't have the right.
What day of the week was he born? You're
Just go with it,
guessing.
go with it, go with
Tuesday.
Oh, it was a Monday.
I was about to change it to Monday, and I should have just not went with my gut.
Okay, Brandon, we're gonna do Miss Priscilla Ing.
it. Many friends. Are these your only friends?
Pretty much. You caught me. Yeah.
Sunday.
Wrong. Wednesday.
So many Wednesdays.
What?
So many
A lot of
Wednesdays.
It's true. All right, we'll do Miss Lisa Stone. All right, Allie.
Thursday.
It was Thursday.
Yay!
6 problems.
No, we don't count the ones that we got
Yes, it
right.
does. It says the number of guesses.
Caught me.
Oh, it
Wait,
is.
it did say.
Number of guesses, not the numbers correct.
All right, so the question is
Guesses
this
made by
a
Flash.
is this a random
Just
variable? Is this
It's not real, is it?
binomial? Is this a binomial situation?
No.
The last one counts.
All right, so guess what? We are leaving bins behind. Our cute little bins are going
Okay,
away.
it's just one problem. That's the way it
And we're
works.
gonna pull out this. And who can tell me what this
A
is?
filing
You
cabinet.
might be able
A
to
grill.
tell. I think you got the last one. We'll start with Julia. What is that?
It
No,
looks.
think of it. It's probably like a 4 or 5 letter
blurry.
word.
They look like lots of different little screws or
All right, what's the name of those things? Not little screws. What are those called?
Oh, I know what it is.
What? You gotta think of the word.
Show them to Lena.
We're trying to guess what these are. Because we're not using bins anymore. We're meeting a new random variable.
Are they arrows?
Nope. Is it in the right spot?
Yeah, she can see.
Kind of a blurry picture. I had to enlarge it.
Oh, it's the villager. The thing for the drill.
So what?
Drill bits.
Bits. She got it. All right.
I remember right now.
We're no longer doing bins, we're doing bits.
Love muffin.
Alright.
Bring your baby
Alright.
here.
Taking notes on the new information. This new random variable will be named in a minute. I think you see it on your paper there. And it's called a
Bits.
geometric
This is like
random
the same
variable.
thing as bins.
Bins, bits, bits.
Geometric random variable.
So it's
Well,
not about a fixed number of things.
It is
It's
not.
about a
Trials. Is it on trials?
Number of trials.
It's trials.
Alright.
Stop.
It is. It is.
Somebody hit him and stop him from
Yeah,
reading.
yeah, please. Alright.
That's what you do to things in a nice
Alright,
way.
so here's our test for
That's hard enough.
I'm sorry. I should have hit
If
you
you do
harder.
that
Alright,
computer like that, it wouldn't
Caleb.
respond at all.
kids.
Just laugh at you.
When you're looking
It
for a
would not.
geometric random variable, it is still binary, yes or no. So in the birthday game, you either got it right or you got it wrong. The trials are still independent of
Yes.
one another.
And it's still saying.
If you got the one, doesn't affect whether your next person gets one or not. And the trials is, the number of trials varies. Number of
Oh.
trials varies.
Oh, then yeah.
This is the average.
So why?
Right, so it depends.
Why don't we?
We're
do
just
X
gonna
with
keep
fixed
going
number?
until we hit our first success. So, stop
Number of
after
trials, and then
Number
first
of trials.
success.
Um,
Success.
This doesn't make sense.
That's what they do, trials, sorry.
They-
Sorry you don't like
Oh,
it.
we, I know, I mean, we can.
Alright,
we
number
don't
of
have to do
trials
them.
varies. You stop after your first success. So it could be one trial or millions of trials. And lastly, the success is the same, the probability of success is the same for each trial. So everything's the same for bins and bits except the T. All right.
It should be. It should always have been bit.
All right, let's look at the probability of playing the birthday game. If you would write this probability around, we usually, a lot of times when it's a geometric probability, they use Y. It doesn't have to be, but I will go with the convention.
NDP of G.
The probability of this geometric variable equaling, we want to know if we only get, what was the probability of getting only one homework problem? So, in order to calculate that, we have to know what is the probability of guessing the right day of the week. What is it?
1 out of 7.
Right, 1 out of 7. So that is the probability that y equals 1 for the birthday game. Let's do y equals 2. Let's see if we can come up with a general probability. This will be a lot easier than with our binomial, which took us like a whole day and a half to come up with that one. So the probability that y equals 2 means that you were wrong on the first one and right on the second one. So what's the probability, Daly, that you're wrong on the first one in the birthday game?
6 out of 7.
6 out of 7, followed by the probability that you were right. So that will, I don't really care what the number is, I'm looking for a pattern. So, Caleb, construct what y equals 3 would look like. So we would have wrong, wrong, right.
So 6 out of 7, 6 out of 7.
Right. And I think you get the gist here. So let me do one more, Julia. And then we'll see if Brandon can wax wise and tell us the general one. So you watch for a pattern, Brandon. You're going to be called on in a second. So probability of y equals 4, then Julia, you want wrong, 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 right. So,
6 over 7, 6 over 7, 6 over 7, 1 over 7.
right. All right. So now, Brandon, what would you think the probability of y equals any number on k when we're doing this kind of random variable? So we're going to have the number that are, let's say that the probability of success is p. We'll write a little script p like that. So what do you think we're going to do in general? for any geometric random variable. So something, what did we do when x, y equals 1?
1 over time.
This was p, right?
Yes.
And what happened, how many p's were there when y equals 2?
It's 1.
How many p's were there when y equals 3?
1.
And how many p's? So we're always getting we're getting two things multiplied together. We're always getting 1 there. So what are we always getting in the front? So when y equals 2, we got 1 minus p, how many times?
Just 1.
And when y equals 3, how many 1 minus p's were there? And when y equals 4, how many 1 minus p's were there? So in general, if we're looking for k, 1 minus p occurs how many times?
1 less than y.
1 less than k, so you're close. K minus 1. Here's the formula for the probability of k, y equals k in a geometric. So that would be how many trials you would get, k trials. So it's going to be the probability of 1 minus p raised to the k minus 1 times p. So let's look at the assignment and cut it down.
So you only get 5 problems?
1, 2, let's see how many they asked. 1, 2, 97, 99, 101, 102, 103. So there were 7 problems. So we will just do the first 4.
Yay.
Alright, so hopefully you've learned enough to be able to do that. At least read the problem and write down what it says. I think that if it asks for the mean, we haven't learned that yet. So you can skip that part.
Okay.
Alright, over and out.
Bye, Lynn.
Bye.